Okay, make this a little more visible. Page width, there you go. I think this is one of my favorite worksheets. And this is what I am most proud of because I have been a maintenance person. And I have done PMs that were based on a calendar. And I think now, if you're a maintenance person, you probably can't implement this, but just keep it in the back of your mind, look for opportunity. Because it's fairly easy to do. Program the following. When a machine is on, the run time needs to accumulate and not reset when the machine stops. So you're going to start a timer, or you're going to have a timer that tracks the run time of a machine. And you can have that timer reset and increment a counter if you need to, because it's probably going to go a while. Okay? But we'll just do it on time. The runtime needs to accumulate, not reset when the machine stops. So that means I will have a non-retentive timer. At a runtime equal to 40 hours, so machine runtime of 40 hours, a yellow light should come on alerting that a PM soon needs to be done. At 50 hours of runtime, a red light should come on. So after 40 hours or 40 seconds, you get a yellow light. At 50 seconds or 50 hours, you get a red light, and this is an indicator that a PM is due. And at 55 hours of runtime, the red light should blink. Now, if you can't remember how to make a light blink, revisit your stoplight program. I get this about every semester. Somebody says, I don't remember how I did that. Well, go back and figure it out. Okay? Make the red light blink at 55 hours. Now, this is a PM for machine based on runtime. You only need one output bit to do the timer. And if the PLC is controlling, you can implement this in a subroutine in an existing program, or you could have a little baby PLC like the Click you've got in your hand, 150 bucks. You could have a PLC looking at the runtime, whatever somebody deems as the machine is running, what output deems the machine is running, and you could PM based on runtime. I think that is more efficient than calendar time. And yes, it does mean that you would get, you could get PM stacked up, but you would be more efficient and you'd be doing less of them over the year, and therefore you'd be getting more product out. So this is a really easy thing, and I don't know why it's not out there, but it's not, at least not that I've seen. So how could a runtime PM program be implemented, especially on equipment already PLC controlled? I've just talked about it. You can do it as a subroutine. You could do it as a standalone PLC. All you got to do is look at an output. It wouldn't even take any current. So now I ask the question, what would a runtime PM save as opposed to calendar PMs? So I've been in an industry where you fix a machine, it breaks, it's down 2 months, waiting on a part, waiting on something. You get the part in, you get it fixed, but it has sat for 2 months. As soon as you get it running, out pops a PM saying, oh, you've got to go PM that machine that was sitting down for 2 months. And sometimes that's a value. I'm not going to say it's not, but I think it would be more efficient from the standpoint of manufacturing, more product out the door every year if you did it based on runtime. Because if you do it based on calendar, Yeah, you can predict when you're going to PM, but that's the only advantage that I see. You might end up PMing too much, which wouldn't be efficient. Okay. How much do inductive proximity switches cost? Find the price and the vendor. I like questions like this because I like y'all to look stuff up. If you're in maintenance or you're doing something in an engineering or some kind of technical field, you know, be prepared to look and find parts. Be prepared to look and find the manuals on how to wire them up. So you've got inductive proximity switches, you got capacitive proximity switches. Price and vendor, price and vendor. Something that you could buy locally. Which type of proximity switch is most often used? That's actually not really a trick question. It's meant to be more informative. The one you think would be the one that is most often used isn't. It's the other one. Because the one you think that's the most often used is actually a little more finicky than the other one as far as environmental changes, dust, etc., will set them off. So they would require more adjustment. The type that isn't as used as frequently, what are the negatives? And I just said that, environmental. So you should find that inductive is used the most, but an inductive one will only sense metal. Capacitive will sense anything. So you think, well, I use capacitive proc switches the most. Well, if you've got something that's not metal, then you have to use it. But what you run into is dust, humidity, differing types of material, thicknesses, whatever, can make these things read all over the place. So they're not as reliable as an inductive proc switch. So generally, if you can use an inductive, you will. If you can't, then you have to deal with the effects of a capacitive one. But finding a price and a vendor is huge, and that's a fun, easy little program to write. And that's worksheet 23. Thank you.